Kia ora koutou katoa, it's Mrs. Goodson here, and I'm going to go through how you're going to do your science investigation using your Poi Toa. So this video is the first one, but there's going to be a series of videos. The first part of the science investigation is to plan, okay? Plan what you're going to do. And then you'll submit your plan to me, and I will give you some feedback on it, maybe make some adjustments, and then you can do the experiment. So why are we doing this? So the scientific method is a process or method of creating new knowledge. A problem or question is identified. Information about the problem is gathered. A theory or hypothesis or question is developed from the information. The hypothesis is tested with an experiment. We do a fair test. Then the theory or the hypothesis is proven to be true or disproven, and then the findings are shared with others. And this scientific method is a way of creating new knowledge. It's a way that the world works out what is true, what is correct, what can we learn, what are we going to do differently in the future. So what I want you to think about, what would happen if new ideas were accepted without being tested properly, i.e. with no evidence? Okay, so the learning objectives for this project is to learn how to plan and carry out a valid science investigation and to learn about forces and motion, which is physics. So what do you need to do? The first part is to plan your science investigation, and you will fill in the planning template on Google Classroom. Once that plan is approved by me, then you will carry out and write up the science investigation, and you will fill in the report template that is another assignment on Google Classroom. So what does the planning template look like? So the first thing you're going to do is list all the things you could change that could affect the throwing or swinging of the Poi Toa. So you just list all the things you could change. You could change how big it is, you could change how much it weighs, you could change the length of the rope. I bet you can think of lots of ways you could change it that will affect how the throwing of it or the swinging of it. In the next box, you're going to list all the things you could measure. For example, the distance the Poi Toa travels, all sorts of things you can measure. You may wish to do some research to get ideas. So you'll find this template on Google Classroom. Okay. To give you some ideas, this is some other science questions. And the reason I've included this slide is to show you the format for science investigation questions. So for example, does the height of a ramp affect the distance a toy car will roll? Does the mass of a car affect the distance it will roll from the bottom of a ramp? Here's another one. Does the height from which a rubber ball is released affect the height that it bounces? Does the surface of the ground affect how far a ball will roll? These are all things that can be tested. So you can see that the format for the question is, does something affect something else? Okay. So once you've done your brainstorming, then you're going to fill in the second sheet on the planning, and this is the planning grid. You want to make sure your experiment is a fair test. A fair test is when you only change one thing. That is known as the independent variable, and keep everything else the same that might affect the results. So these are the control variables. And then you come up with a prediction. What do you think will happen? This is your hypothesis. So you write your aim, your question to be investigated in here. In the green box, you write, what will I change? You only change one thing. And the yellow box goes, what will you measure? And then there are several things that you keep the same. And then at the bottom in the pink box, you write your prediction. So how do you design a fair test? Is your data reliable? Can it be trusted? So you need to repeat your experiment at least 3 times and take the average. If the experiment goes wrong or the data is odd, you would leave out these pieces of data which are called outliers. What are you going to do to make your measurements accurate as possible? How will you make sure only to change one thing? What might happen if you don't do this and more than one thing changes? So this is the end of the first video. And so I want you to go to Google Classroom and find the first assignment, which is to plan your experiment and fill in the 2 sheets. The first sheet looks like this with a green box and a yellow box. And the second sheet looks like this with the variables and the planning.